Anyone else a little sick of modern gaming? Wouldn't it be great if things were simple again? Wouldn't it be great if gaming was affordable again? Wouldn't it be great if this were an awesome segue into the topic for today's video? Well, as you may have guessed from the title of this video, I'm giving myself 1 week to build my own console. My goals for this video are to build a game console from scratch, write an original game for it, fit everything into a 3D printed shell, and end with a console that's genuinely fun to play. So let's talk hardware first. We essentially need a brain, a screen, an input device, and some type of storage. I want to use components that are cheap, but still good enough to get the job done. For the brain, I figured any Arduinos would be too massive, so I landed on the ESP32S3, a low-power dual-core 240 MHz microprocessor with 45 GPIO pins. ESP32s are kind of special because they typically have Bluetooth and Wi-Fi capabilities. This means we can connect literally any Bluetooth controller to our microcontroller and use it. And that's probably the best microprocessor you can get from under $5. Next, I found this TFT color display for $1 and it seems fine. I'm sure the most astute of you have noticed that I didn't mention storage yet, but it's actually built into the ESP32 in the form of an onboard micro SD card module. Alright, sick, that's all the components for only $7. This video will be 2 hours long if I went through all the difficulties getting this ESP clone to boot, so let's just pretend it worked the first time. But yeah, after getting everything wired, I got the ESP to boot and the screen to display an image through graphics calls. Reading the input values from my Xbox controller was pretty trivial. I used an open source library called BluePad32 to get the data. I'll be posting a tutorial soon on how to connect a controller to your ESP32. The link will be in the description if you're interested. With all that out of the way, I can finally get into the programming. I really admire the creativity of building in Minecraft and the platforming logic of Super Mario, so I wanted to mix the two in my game. Here's how it's going to work. The system opens a world file on the SD card, then converts it to a 2-axis array, which is basically a big grid of numbers. Each number on this grid corresponds to a different sprite image. For example, 1 would be grass, 2 would be dirt, and 3 would be stone. I'm going to keep the player collision simple by checking if each corner of the player is inside one of the tiles and pushing the player away if it is. This is actually the same type of platformer collisions that Nintendo used in the original Super Mario Bros. For drawing the level, we first determine which columns are actually visible for that frame, then iterate through the rows of each column. If the tile is 0, that means it's an air tile, so we skip it. If it's something else, we pass it to a function called index-to-text, which takes the tile index and returns the proper texture for that tile. Then we can draw that tile to the buffer canvas. When we're finished rendering out the level and the player, we can blit a bitmap of our buffer to the real screen. I'm pretty proud of the world saving system I built. I think it's more meaningful to the player if they can keep building on the same world each day. It basically just works by loading and saving an integer array to the same binary file on the SD card. In the future, I could add the ability to load different worlds from the SD card since binary files are super tiny. If you want to learn more about the programming side of things, all of my code is in the description. After programming the core game, I had a ton of fun just exploring the world and building random stuff, and I think that's how I knew I succeeded. At some point, I stopped opening the game just to test new features, and I started opening it because I actually just wanted to play it. There's something really satisfying about seeing a game that only existed in your head suddenly becoming something that you can actually sit down and play on your own hardware. But the breadboard is kind of looking unprofessional, so let's make a proper case for it. Designing the case was mostly straightforward. I started out by measuring parts of the screen in ESP and writing down each of these dimensions to use in my CAD. Next, I sketched out a simple design both on paper and digitally. I find it helpful to make a rough draft of the design without exact specifications to better visualize the design before I start my first real draft. In case you didn't know, the software that I use to design all of my parts is Blender, a free open source program for 3D modeling, video editing, compositing, and whatever else. Here, I changed the units from meters to millimeters to design the case at a real world scale so I can 3D print it. Whenever you're designing a new part, you always want to keep your manufacturing method in mind. For instance, when modeling these air vents, I rotated them back about 17 degrees so that I could print them without supports. Can't do that for everything though, so I had to use some small tree supports for the USB-C port at the back. I also added some small screw holes at the base, so I could mount the ESP32 upside down with the header pins facing upwards. In the first version of the case, I didn't account for the screen jutting forward about 2mm, so I couldn't put it together. And I didn't find that out until it printed for about 2 hours. Not to worry, I redesigned the entire case from scratch with tighter tolerances and more careful profiles. But you know the saying, measure once and spend 5 hours reprinting the part. And about a day later, I had the brand new case. Let me tell you, words cannot express how happy I was when the second version actually fit together with the screen. Each print takes about 2 hours, and getting this video out on time would definitely be difficult if it didn't work. However, I noticed the new top still wasn't great. even with a tolerance of 0.15 millimeters, it was still kind of loose. So I redesigned and printed the top only, but this time with 0 tolerance. Yeah, no, that one didn't work either. So I found the shrinkage rate by measuring the real printed part and comparing it to the digital version, then expressing that change as a percent. Then I found the inverse of the shrinkage rate and found that the new length should be 0.483% longer to compensate. So yep, I got the top for the case to fit on better after like 3 redesigns. I'm super proud of the finished result. It really gives me that pure feeling that older games did. Something about the low quality 16-bit graphics brings me back to that Christmas when I got my DSi. The entire assembly ended up being $7 in total, which is 10 times less than GTA 6. If you want to build this for yourself, go check out my GitHub. I have all my code, textures, 3D models, and G-code out there for you. Thank you for watching. I hope this video was cool or at the least informative for you. If it was, please consider liking the video or subscribing to my channel for more. It helps out a ton. See ya.